All right, so the problem here is you've got essentially a circle that you're cutting a wedge out of, and whatever's left, you're going to roll into a cone. It's going to have a, a circular base coming up to the top, so that this point C in the middle actually ends up being C on the top, and that A and B both end up put together, right? That these two pieces get put together in order to make this cone. And we want to find as large a volume of cone as possible. So large a volume, I'm going to need volume of this thing. Well, the volume of a cone is 1/3 of the area of the base times the height. Well, the base is a circle, so it's going to be 1/3 pi times some radius squared, let's call that r, times whatever the height is here. Okay. Now, what's not immediately obvious is how any of this relates to the circle you started with. Well, let's work our way through it. The distance from A to C or B to C is 14. So this slant distance here has to be 14. The radius here is not going to be the radius of the original circle because the original circle, you know, goes all the way around, and this has got a shorter circumference. But, okay, here we go. Somehow I have to describe what's being cut out, or maybe what's being left. I think it's going to be easier for me to use as my variable. Let's use the variable theta here as that angle, whatever angle is left. And because I use that, the arc length here, the arc length is pi, no it isn't, it's r theta, right? It's a radius times the angle. So the radius is 14, so the arc length is 14 times theta. All of that arc length is turned into this circumference. So 14 times theta has to be 2 pi times r, which tells me that r has to equal 14 divided by that. So 7 theta divided by pi. So that's what I want to plug in for r here. So I've got 1/3 pi times 7 theta divided by pi squared. So knowing how much angle I have left here, that tells me what my radius is, but it should also tell me what my height is here, because that height, h, is the square root of 14 squared minus r squared, but r is 7 theta over pi squared. So this is the square root of, yeah, whatever that is, 14 squared minus 49 theta squared over pi squared. And that is what I can plug in here for h. What I have here now is the volume of the cone as a function of theta, and theta is the amount of angle that I have left. That's essentially the size of the wedge that I'm using to make this. Right? So theta is going to be at most 2 pi and at least 0, right? Somewhere between 0 and 2 pi. I am not going to finish this problem right now. I am going to leave it for you to solve. But this is the setup. Here's the function now that needs to be maximized. So you need to take a derivative, set it equal to 0. And I think you might be able to do that.